What's up, guys? We're gonna go over a quick code vulnerability demonstration today. So we're going to perform a stack smashing attack. This is when someone takes advantage of a vulnerability in some code where a buffer overflow is possible. So what is a buffer overflow? Essentially, it's a block of memory which gets written with another block of memory that is larger. So to give a simple example, you've got a 32-byte block of memory allocated, okay? And you want to copy onto that block of memory 64 bytes. Now 64 bytes doesn't fit in 32 bytes, so all sorts of things can happen. One of these things, well, the first thing that will happen basically, and what will eventually happen really, is the buffer will overflow and the stack will get corrupted and the program will crash because the program doesn't know which instruction to go back to, or it will be an invalid memory address, and when the operating system tries to run that instruction it will crash. So what we're gonna do is we're gonna take advantage of that vulnerability to take control of the program by hijacking the return address. Okay, so over here we have a very simple test program. All it does, okay, it starts from here, from main. It opens a file over here, file.txt. Okay, it will allocate a 32-byte buffer. It will read one line from the file onto another buffer which gets allocated, and then it will copy that buffer onto this 32-byte buffer. So basically we're simulating a buffer overflow because this function here is not the best function to use, and this is why this is our vulnerability. So one has to be careful what functions to use and what they do. Okay, essentially the program will also print the buffer that's been copied and will exit. Okay, so that's all this program does. Now over here we've got a file. Let's do this. Okay, we've got a file that's much better. Okay, and we've got the first line, so the program will just read the first line and print it out. Okay, before printing it out it will copy it onto the 32-bit byte buffer. So if this line is smaller or equal to 31 bytes, 32 bytes with the null, it will work. If it's longer, well, you don't know what's gonna happen, so not necessarily. So if we run it now, if we run the test program now, we can see it just it's just done what we've just said. It's just copied it's just read the line from the file and printed it out. So nothing new there. Seems like this line fits into a 32-bit buffer because the program finished successfully and it didn't crash. Now if we change this file such that we have more than 32 bytes and run it, okay, so now we've got a longer line. Okay, if we run it, we've got a segmentation fault. So what's that saying is that the program is trying to execute an invalid, it's trying to get an instruction from an invalid memory location, one that may not be accessible by this process for whatever reason. Now what happens is, yeah, in Windows it will bring up that funny little box which says, oh, Windows caused an illegal operation, yada yada yada. Basically the program crashed. So this is why it's important to avoid buffer overflows and to use the right functions and ensure there's no writing to incorrect memory addresses. On to the demonstration. Okay, let's have a look again at the file. Now when we did this test, we've done some analysis on the binary file with knowledge on binary files, ELF in Linux, executable linking format, and portable executable PE files in Windows. Okay, one will understand how to get the address of a function. So what we have done is basically position the stored in this text file here. You can see this funny set of characters. That's an address. Okay, it's positioned specifically in the right location so that just after the buffer gets overflowed, the stack will get corrupted and the return address will be written with this new address. Now this is a function within the binary itself. So one might argue, well, you haven't done much. Well, you actually have, because you can make system calls, operating system calls. So you can actually run a process and hijack the machine by hijacking the executable. So let's have a look at this now. Okay, so basically what we're gonna see is we're gonna see the program run the top function that we have seen before. Oops. Sorry, I'm just getting distracted here. So what we're gonna do is we're gonna run the program's gonna stay the same, but because we've put that address in a location which is above 32 bytes for that buffer, that address is going to be executed, and that addresses the function stack smash attack, which will print out this line a bunch of times and exit the program as well. Okay, so basically I took control of the program this way. Yep, so let's run it. Let's just check the file. Yep, so there you go. It doesn't look like there's anything funny here, but there is, okay, in this file. If you do a hex dump, actually, I don't know if I have a hex. Yep, hex dump file.txt. You can see somewhere here. Ooh, okay. I think we can do this. Here we are. There, that's the first line. Over here, this is your memory address. So over here, this is a memory address. Not that, this one here. That's our memory address. That's an offset. Okay, so that's a relative virtual address. We don't need to get into those details, but basically we run the file, and as you can see, the program got redirected. So that was a little bit of a demonstration. I hope you enjoyed it. I hope it was educational. The idea is avoiding buffer overflows. Thank you for watching. Yeah, thanks.